Hello everyone, my name is Fatia. Today we are going to learn inertia in 15 minutes. Are you ready? Okay, let's start our class now. For everything that we do or for every lesson that we go, there must be an outcome that we want to obtain from it, right? So, to start, we will go through the objective of our lesson. Since you are going to learn about inertia, at the end of this, you must be able to explain with examples the concept of inertia. And next, you can use your analyzing skills to do an experiment to find the relationship between inertia and mass. And lastly, you will be able to justify the effects of inertia in daily life. Now, I have a question to ask. Have you ever need to stand in bus or train? You know, the one when you are late to get into a bus and there's no seat available for you? Or even at that time when you are sacrificing your seat for older people or a pregnant lady? Don't worry, if you have not been in that kind of situation, let me visualize it to you. Okay, let's take a look. Here, we have a few people standing in a bus. When the bus driver starts to move the bus as the light turns green, we could see that the standing people are moving backwards. Contrary to the previous situation, the standing people's body moved forward as the bus stopped moving at the traffic light. Worst case comes when there are even people who can fall straight on their face if they are not holding the handle firmly. So the question is, why does this happen? This can be explained with the Newton's first law of motion, where it states that if there's no net force acting on a body, its state of motion will remain unchanged. This law is sometimes called the law of inertia. In simpler words, when a body is at rest, it will remain at rest. If the body is moving, it keeps on moving at a constant speed in straight line. Okay, let us get back to the situation before. In the figure, when the bus suddenly moves forward, the feet of the passenger are made to move forward. The inertia of their body tends to remain at rest, hence they are falling backward. Okay, now let us take a look at the second picture. When the bus suddenly slows down, the feet of passenger are brought to rest. The inertia of their body tends to continue moving forward. Hence, they fall forward. Okay, are you still with me? Okay, now let us proceed to other situations involving inertia. The first situation is when the coins maintain its state at rest. So what we have here is a glass, a cardboard, and a coin. So when the cardboard is pulled, the coin falls in the glass. This is because of the inertia of that coin maintains its state at rest and falls into the glass due to gravity. Okay, we go to the next situation, which is forcing sauce out of its bottle. When it is hard to take out the sauce from the bottle, a quick downward jerk is needed to force it out of the bottle. So what we are going to do is tapping at the bottom of that bottle, right? So to explain this, when the bottle moves, the source in it moves together. When the bottle is stopped, the inertia of the source keeps it moving downwards and out of the bottle. And then you can enjoy your sauce. Okay, so let us go to the third situation here, which is books above tend to stay at rest. So look here, we have a stack of book, and then suddenly the book at the middle is pulled horizontally with a quick jerk. However, the books above it tend to stay at rest. This is actually due to inertia. We go to the last situation in this lesson, which is a driver thrown forward during an accident. The figure shows a driver crashing his car without wearing his seatbelt. Both the driver and the car were traveling at a very high speed. When the car was stopped suddenly, the inertia of the driver caused him to be thrown forward, thus injuring himself. Okay, this is a lorry and a bicycle right next to it. It is more difficult to move a lorry than a bicycle when they are initially at rest. When they are moving, it is also more difficult to stop the lorry than the bicycle. The question is why? Actually, this is due to more inertia happening for the lorry than the bicycle. The lorry has a bigger mass than the bicycle. Hence, quantitatively, it has a greater tendency to be at rest than the bicycle, and of course, it also has a greater tendency to continue to be in motion than the bicycle. So, what I am talking about here is larger mass meaning more inertia, and also smaller mass means less inertia. So, of course, there will be need an experiment to prove the situation, right? Okay, this is one of the experiments which we can use in order to know the relationship between inertia and mass. So what we're gonna need is a G-clamp, a hacksaw blade, a bunch of plasticine, and also a stopwatch. So this is basically the image of what we are going to do in this experiment. So the first step is clamping the hacksaw blade with the G-clamp. So here we have a hacksaw blade and a G-clamp, and then we clamp it all together at the table leg. And then we attach the plasticine with a mass of 30 grams. So we attach 30 grams of plasticine here. Actually, for the mass, it depends on you on how much you want to put firstly. And then we displace the hacksaw blade slightly sideways and release it. Use a stopwatch to record the time taken for 10 complete oscillations. And lastly, we repeat step 3 and 4 with different mass of plasticine. So here, I use 30 gram, 40 gram, and up to 70 gram for the mass. You can tabulate the result and plot a graph for your analysis. If you do that, you will get a graph similar to this one. Based on this experiment, we can observe that a larger mass of plasticine attached to the hacksaw increases the period of oscillation. The reason behind the use of period is it can be used as an indicator. The bigger the period of oscillation, the bigger is the inertia of the plasticine. Hence, bigger the mass of plasticine, bigger its inertia. So, if any one of you which can't remember the period formula. So this is it, where the time taken is divided by 10 oscillation. Okay, now we are going to share with you the effects of inertia in daily life. So, this is a ship. This ship cannot be stopped immediately. Due to its very large mass, a ship has a very large inertia. It cannot be stopped quickly, even during an emergency. A very strict navigation system is needed to guide a ship when reaching a port, sailing near rocks and icebergs, as well as in busy sea routes like the Straits of Malacca to prevent accidents from happening. Next, we look at this situation where the load moving forward when the lorry suddenly stops. So what we are going to do is we place a steel structure in between the driver and the load. So you can see the steel structure is the one in the red circle here. The steel structure prevents the load from moving forward and knocking over the driver compartment when the lorry stops suddenly. Okay, the other effect of inertia in daily life is an aeroplane which cannot be stopped easily. An aeroplane has a large mass. It cannot be stopped easily when it lands at airport due to its large inertia. Therefore, a very long runway is required for the aeroplane to stop safely. Next, we have a driver who move forward during an accident. When a car stops suddenly during an accident, the driver continues to move forward because of inertia. The safety belt and the airbag prevent the driver from crashing into the windscreen and injuring himself. That is why normally the new car have already inserted the airbag system in their car system. And you need to remember to always wear your seatbelt whenever you are driving or even when you are at the passenger seat. The last effect which I am going to show you in this lesson is where the skaters glides almost effortlessly. After an initial push, an ice skater glides almost effortlessly and gracefully on the icy surface because of inertia. Okay, since you have already learned, let's answer a few questions. So, the first question here, it shows that we have two buckets. One is empty and another one is full with sand. So, the question asks you is, why is the bucket with sand is more difficult to be pushed and more difficult to stop? Okay, let me show you my answer. So the bucket filled with sand has a greater tendency to be at rest and stay in motion as it has larger mass than the empty bucket. Thus, it has a greater inertia. So, the greater the mass of an object, the greater the inertia. Just so you know, there might be a question which will ask you to prove this statement. You might as well conduct an experiment just like what I have shown you before. We go to the next question. So the second question asks you, which phenomena shows the effect of inertia on a moving object? Is it the racing car can go faster than an ordinary car? Or a car passenger flings forward when the driver suddenly brakes the car? Or a lorry takes a shorter distance to stop completely than a car at the same speed? or even an aeroplane which can fly higher than a helicopter? So which one would you think that shows the effect of inertia on a moving object? Yes, the answer is B. A car passenger flings forward when the driver suddenly brakes the car. This phenomena shows the effect of inertia on a moving object. Okay, that's all from me. Thank you.